Hi, welcome to the Getting Started video for problem 7 of the CATS project. And in this problem, we're going to implement the minimum mutations function, which is a more advanced diff function that can be used to autocorrect. And this function should return the minimum number of edits operations needed to transform the entered word into the source word. So by edits, there are specifically 3 different types of edits. And the first one is to add a letter to entered. So here our entered word is eaten, and we can add the letter K towards the front, and this would give us the source word kitten. And then the second type of edit is removing a letter from the entered word, which here our entered word is as cat, and we can remove the letter S, and then it would give us the source word cat. And then we have the third type of edit, which is substituting a letter from the entered word. So here, we substitute Z with J in our entered word, that would give us the source word here. So knowing these 3 type of edits, there's also another parameter in this function, which is called the limit. And here it says, if the number of edits required is greater than the limit, then minimum mutations can return any number that is greater than the limit. For example, you can do limit plus 1, and then the function should stop making recursive calls once the limit has reached. This can save us time and memory. So here we can check our skeleton code and we can see this minimum mutations function has 3 parameters: the entered word, the source word, and then the limit. And then using these informations passed in when the function is called, we can determine the number of edits needed. So to better understand this question, let's look at the doc tests. So here we set our limit to 10, and our first call to minimum mutations is our entered word is cats, and our source word is ascat. So we want to make some edits to the word cats and to turn it into ascat. So here are the steps we made. So we first entered another letter towards the front of cats to make it as cats. That's our first edit. And then our second edit is to remove the S in the end. That would make the word ascat. So that totally give us 2 edits. And since 2 is not greater than 10, we can just return how many edits we made. And then our next example would be our entered word being prong, and our source word is purring. So we can see here, our first edit will be entering another R, and then our second edit is entering the I. And then that's 2 edits as well. And our third one is our source word is this word, and we want our entered word is this word, and we want to edit it into the source word kittens. And our edits made is by first deleting the C at the front, and then adding a T in the middle, and then substituting U with the N. And that is going to give us a total of 3 edits. However, in the examples down below, we can see that after changing limit to 2, we know that these 2 words need 3 edits, so that we're going to return a number, an integer. No matter what it is, it should just be greater than limit. And similarly, these 2 words requires a lot of edits, that's greater than 2, so our return value should just be greater than the limit. But make sure to stop after the limit number of edits is reached. Yeah, this is a very long question, so make sure you read carefully of the question statement and the skeleton code and the doc test before you start coding. So now, if everything's clear, let's get started. So our skeleton code here give us some hints. So first, we start with the base case. I really suggest for any recursive functions, think about base cases in the simple kind of situations that you can just return the answer. And here they also said in the skeleton code that you might need more base cases. So think about when can you know that, oh, there's no more edits needed, or when can you know that maybe I reached the end or I reached the limit. What should I do? What can I automatically return? And also, we have a bunch of recursive cases. So I think the challenging part of this question is that there are multiple type of edits that are here, so that we have multiple recursive cases or recursive calls, and we can try to like put them one by one here in our recursive case section. Um, I guess for recursion, it's very important to split things into cases. I mean, the three cases would be the three type of edits. And also another case would be this current letter does not need an edit. So think about how to check it and how to kind of keep track of how many edits you've made. And yeah, and I think our last suggestion would be the key part of the question is in these three lines. So we know as we read from the question statement that we know what add does, we know what remove and substitute does, but how to represent the specific edits in your recursive call, and think about there are many different ways to potentially edit this word. And there's one singular way to edit this most efficiently with the least number of edits. So how can we use the principles of tree recursion to make sure we always return the sequence of edits that has the least number of edits? So I think this question will really help you understand tree recursion more. And I suggest you, if you get stuck, maybe look at some of the common examples of tree recursion, such as walking up the staircase example we did in lecture. This can be really helpful and serve as a base knowledge for this question. Good luck on solving problem 7. And if you have any questions, feel free to ask on ed or come to office hours. I hope this helps. Thank you.